This video is for class 7 physics, and in the previous video we just learned how to draw an image of a point object. So in this video we shall learn how to draw the image of an object of finite size or extended object like this here. So we'll try to learn how to draw this. So if you try to draw this with a free hand, the problem we'll face is this distance here might not be equal, right? And this image here might be shifted here or here. That's what happens generally. So let's try to learn how to draw this figure. Now to draw that figure, again like the previous case, I have taken a blank paper and I have marked one point A. So I have drawn a line which represents the mirror. This time I am not shading it, so you can see I have taken 4 centimeter on each side like previous ray diagram, and this time I am marking it as A and A dash. So now since it is an extended object, so I am extending it till 3 centimeter. You can mark it at any centimeter, and I am marking it as B. Now the distance from the mirror of B is 5.5 centimeter, right? Is 5.5 centimeter. So at the top also in a straight line I should take 5.5 centimeter. So here I am taking 5.5 centimeter and marking it as B dash. Okay, the next point, the image of B. So now I shall join these 2 points, right, which is the image of the extended object. Okay, the next point I should mark it as B dash, and from the point A, like previous ray diagram, I am taking one incident ray, and from the point A dash I shall make dotted lines which represents that A dash is behind the mirror, and then a straight line which is my reflected ray. The previous one was incident ray. Then from the point A I am taking another incident ray which strikes the mirror, and it should have a reflected ray which needs to start from A dash. Again I am drawing a dotted line and then a straight line outside the mirror. As you have seen, now I think I can join A and B. I think you have seen that any line behind the mirror should be dotted. So again I am taking an incident ray striking the mirror. Okay, this is the incident ray. It also needs to have a reflected ray which should come from the point B dash. So I am taking one dotted line. As you can see, this dotted line represents B dash is behind the mirror. It doesn't matter if the line outside the reflected ray intersects with each other outside the mirror. Now another incident ray which is striking the mirror, and then a reflected ray. First the dotted lines and then the reflected ray. Okay, fine. So we have the object and image. So here we can see the object and image and the formation of the image of an extended object. So I think you can draw till here, okay, and if you want to draw normal and angle of incidence and all, that's up to you, but it will make the ray diagram more complicated. So the conclusions which we get from the above ray diagram, and the ray diagram from the previous video is that for an object in front of a plane mirror, the image is formed behind the mirror. That's why the dotted lines was used. It cannot be obtained on the screen, right? Like in your cinema halls, like in your school, when you watch educational video on the whiteboard, those images are formed on the screen, but plane mirror cannot form those kinds of images, right, on the screen. Therefore it is a virtual image. That means the image which cannot be formed on the screen are considered to be the virtual image. Remember, this is not the definition of virtual image. It's just to identify whether the image is virtual or real. So this image is formed when the reflected rays are produced backwards, which was shown by the dotted lines. Now number 2, the image is as far behind the mirror as the object is in front of the mirror. As you have seen in the diagram that I was very cautious to measure the distance, that is between A and A dash, that is between B and B dash. So the distance between A and A dash was 8 centimeter and 4 centimeter each from the mirror, right? And the distance of B and B dash was 5.5 plus 5.5, so which was 11 centimeter, and they were equally divided between the mirror. So next, the image is of the same size as that of the object. Obviously the image should be of same size. So when you stand in front of the mirror, when you look at yourself, you will get the image of your own height. The image is erect, which means when you stand in front of the mirror, you see your head at the top and leg at the bottom. This means it is erect, it is upright. In the next video, we shall discuss about real and virtual images.